You ever see this happen? A student who is absolutely brilliant, knows their stuff inside and out, somehow gets a bad grade on a science test? Well, today, we're going to look at a simple but powerful framework that can fix that. It's all about teaching students not just what to say, but how to say it. I mean, we've all seen it, right? A student you know is bright. You know they get the material. But when they hand in that test, the answers just miss the mark. So what's going on here? It is probably one of the biggest frustrations for any educator.
And here it is. This is the whole secret. The problem usually isn't their knowledge. It's that they're fundamentally misreading what the question wants from them. They're giving a great answer to a totally different question than the one on the page.
So, this brings us to what I like to call the hidden hurdle. It's this invisible wall that stands between all that amazing knowledge in a student's brain and a top-scoring answer on the paper. You know, the real challenge boils down to these three things. First, students see a command word, like describe or explain, and they don't get that it's a super specific instruction. That means they don't switch on the right level of thinking, and because of that, their answer just isn't structured the way it needs to be to get full points. So how do we get students over this hurdle? Well, we need to give them a decoder ring for the language of exams. We need a system that basically makes all those hidden rules crystal clear. And that system is the command word ladder. It's this really elegant framework that directly connects the verb in the question, the command word, to the exact type of thinking they need to do, and it even shows them how to build their answer. This right here is the whole philosophy in a nutshell. It trains students to just pause for a second and run this quick mental checklist before they even start writing. By asking these three simple questions, they stop just reacting and start intentionally crafting a perfect, high-scoring answer. It's a game changer. All right, so let's actually climb this ladder ourselves. We're going to go through it rung by rung and really see how the level of thinking gets more complex as we go up. Okay, here they are, the 5 levels of thinking that the ladder lays out. We start at the bottom with simple recall, and we work our way all the way up to complex synthesis at the very top. Each level is tied to specific command words, and each one asks for a more sophisticated thought process than the one before it. So let's start at the bottom. Level 1 words like identify or state, they're just asking for pure memory recall. If the question is, identify the molecule of heredity, the answer is just DNA. Boom. Done. Short, direct. But if we go one step up to level 2, we get describe. Now that asks for a little more, a simple sentence about what something is or what's going on. Okay, pay attention, because this is where so many students get tripped up. The word explain can mean 2 totally different things. Explain how is all about a process. It needs a sequence. First this happens, then this happens, and next this happens. But explain why is about cause and effect. It needs a logical connection, using words like because or therefore. They sound almost the same, but the answers are completely different. And at the very top of the ladder, we hit level 5. This is where students are asked to construct or develop an entire scientific argument. It's like building a case in court. They have to do 3 things: make a clear claim, back it up with hard evidence from data, and then connect those 2 with their scientific reasoning. This is the peak of scientific thinking. Okay, so once students really get a feel for those 5 basic levels, they can level up. They can start mastering the advanced commands. These are the words that truly separate a pretty good answer from an absolutely exceptional one. Just look at how subtle the differences are here. A question asks you to support a statement. What do? You give evidence, and that's it, just the facts. But what if it says justify? Now you need the whole package: the claim, the evidence, and the reasoning. And then evaluate goes even further, asking you to make a judgment call. Is this a good argument? Why? And then defend your position. And this is where you see those common mistakes pop up. A student is asked to explain why, but they just describe a process. They never actually connect the cause to the effect. Or they're asked to support, and they start explaining everything instead of just pointing to the data. Every command word has its own specific trap, and this framework helps students see them and sidestep them. So what's the big picture impact of teaching this way? It creates this fundamental shift in how students think, moving them away from just random guessing and towards real, authentic scientific reasoning.
And honestly, the transformation is huge. Students go from just guessing what the teacher wants to intentionally decoding the question. They shift from rote memorization to actually applying what they know. And all those weak, rambling answers, they turn into structured, confident, powerful scientific explanations. And this isn't just a theory. It has a real, measurable effect in the classroom. The latter directly improves how students answer questions and builds up their reasoning skills. It massively cuts down on how often they misinterpret what's being asked, and it also happens to align perfectly with modern science standards. Now, for any educators watching, this is the best part. It's incredibly easy to put into action. This is literally a 5-step plan. You start by just teaching the ladder itself. Then, you weave it into everything you do: daily discussions, homework, tests. You make students identify the command words. And finally, you track how they're doing on each level so you know exactly where they need a little extra help.
At the end of the day, this is not just some test prep trick. It really is a foundational tool. Mastering this way of thinking sets students up not just for one exam, but for a lifetime of clear, evidence-based thinking and communication. It's about long-term scientific literacy.
And that really leaves us with one last question to think about. Imagine the kind of confidence your students could have if they felt this empowered. What could they really achieve if they knew not just what the answer was, but exactly how to give it?